Hi everyone, good morning. Today we are going to study about inverse function. If I already know about function, have studied about function, its properties. Today I'm going to discuss something about inverse function, its definition, examples, some problems, right? So And what is you? I think you have already studied about this inverse function uh, from the your plus 2 portion onwards, right? So you have studied about inverse trigonometric function, inverse sine, inverse cos, inverse hyperbolic, right, etc. Then we are going to here you are going to study in detail what is inverse function, right? Actually, what is inverse function? Which is a function that reverses another function. Inverse function means inverse. The word from the word meaning itself, we can say that it's a function that reverses another function, right? So if x is a domain, x is a domain, y is a codomain. If f is a function from x to y, then inverse function which is denoted by f inverse and is a function from which reverses this function, which is a function from y to x, right? So it's a function that reverses another function. Let's look the definition from the textbook, right? A function g is the inverse of the function f if f of g of x equal to x for every x in the domain of g. And also one more thing, g of f of x equal to x for every x in the domain of f. Or equivalently we can say that g is the inverse of f if y equal to f of x if and only if x equal to g of y for every x in the domain of f and for every y is in its range, right? So what was the definition of inverse function? That is y equal to f of x if and only if x equal to g of y, right? So or another equivalently we can say that f of g of x equal to x and g of f of x equal to x, and this condition must be satisfied, right? So do not confuse with a f inverse x with a, which is a, this is a node. You do not confuse with a f inverse x with a f of x whole inverse. These are two different. F of x whole inverse is equal to 1 by f of x, but f inverse x is a function which reverses the function, right? Not 1 by f of x. Okay, so inverse of a function is normally denoted by f inverse and is read as f inverse, right? We will not use this notation f inverse always, right? Next up, I'm going to explain this inverse function in detail with an example. Show that the function f of x equal to x raised to 1 by 3 and g of x equal to x cube are inverses of each other. How can you solve that? How can you find out? How can you show this are inverses of each other? We have f of x equal to x raised to 1 by 3. So for that, you have to check whether this f of g of x equal to x and g of f of x equal to x, right? So I am taking the f composition g of x. F of g of x means f composition g of x equal to f of g of x, which is equal to f of g of x means f of x equal to x raised to 1 by 3 and g of x equal to x cube. So f of x cube, that's equal to, this is f of x cube, f of x equal to x raised to 1 by 3. In the place of x, here it is x cube. So x cube raised to 1 by 3, which is equal to x. Okay. And also we have to check whether this g of f of x is equal to x or not. Right? So this is g of f of x, which is equal to g of x raised to 1 by 3. Right? And this is equal to x raised to 1 by 3 whole raised to 3, which is same as x. Right? So we can say that here f of g of x equal to x and g of f of x equal to x for every x in the domain of g and for every x in the domain of f. So f of x equal to x cube and g of x equal to x cube are inverses of each other.